Okay, good day, everyone. Before we get started, do you have any questions? Okay. All right, so we're going to continue where we left off from before the spring break. Okay, so first of all, let's finish section 3.3 on annuities. So open the PowerPoint and we go from there. So let me open the PowerPoint, and then we actually completed question 6 from last class. So we're going to continue from there. So we start on question 7 about question 6. Question 7. Let's look at the total ending balance after 20 years of monthly payments of 1,000 into two different.
You have to reshare your screen.
Oh, okay. Sorry.
The
screen. Yes. Thanks for a reminder. Okay. All right. How about now? Can you see the screen?
Yeah.
Great. Perfect. Okay. So we have two people here. So basically, these two people putting $1,000 in two accounts, right? One of them pay 5% interest, the other one pay 10%. Okay, now you want to find out the ending balance after 20 years. Okay. So first of all, let's look at what kind of annuity is this. Is it the present value or future value of the annuity? Anybody have an answer for this? Okay, ending balance, right? That means it's future. So it's about future value. This annuity. Okay, so we know it's future value of the annuity. And also one more thing we know is we are making the monthly payments, right? Towards those two accounts. One of them pay 5%, the other one pay 10%. So now look at the 5% interest one. Let's compare the difference. Okay, so we already know. Also, we have for annuity 2 elements, right? Future value of the annuity. So this is lump sum payment we're talking about. Lump sum. Okay, we have lump sum. We have a monthly payment. Okay, so we also have another element. It's called regular payments. That tells us this is definitely an annuity. It is a future value of the annuity. So we use a future value of the annuity formula to calculate ending balance. So right here, future value equal regular payment times open square bracket. And this is 1 plus R over N to the NT power minus 1, close square bracket, R over N. So here, let's see what's given. All right, so regular payment definitely is given. It's $1,000 for both accounts. So this is definitely true, 1,000. The rate, annual interest rate is 5%. Turning to decimal is 0.05. And then N is equal to 12 because it's monthly compounding, right? It's monthly payment. So N equal to 12. We also know T. T is 20 years. Once you know all of these informations, we plug into the future value annuity formula. So you get 1,000 times open square bracket 1 plus rate is 0.05 over 12. Now raised to 12 times 20 minus 1. All right, and then divide by the interest rate per compounding period, which is 0.05 over 12. Okay, now let's see what that is. We just have to use a Excel or calculator to do this. Let's get ending balance for this account. Okay, now one more time, let me show you how to do that in Excel. Okay. Let me delete those two. So first one is 1,000 numerator times open parentheses 1 plus rate is 0.05 over 12 and raised to 12 times 20, close it, minus 1. and then you close the numerator, right? And then divide by denominator, open parentheses for denominator, 0.05 over 12. Okay, now once you input like that, then we have the answer right away. And this turned out to be, let me turn into it. Okay, $411,033.67. Okay, so we go back. So this is $411,033.67. So this is total ending balance, right, in this account. And for the 10% one, very similar. Maybe you guys try this really quickly. I give you a couple minutes. It's really helpful if you try first. Okay, and we're gonna go over the answer in a bit. All right, go ahead. And then take a look at the attendance really quickly. All right, let's look at the answer. Again, the regular payment is 1,000. The rate is 10%. Turned into a decimal is 0.1. Okay, and also the n is equal to 12, and then time t equal to 20. Okay, very similar setting, except the rate is double, right? Doubling the rate. Let's see if you double the rate, does the ending balance double? Okay, let's see. Okay, so future value of annuity equal to regular payment times 1 plus r over n to the nt minus 1. Okay, and then divided by r over n. So one more time, we're throwing out the numbers into the formula. So 1,000 times 1 plus, oh, my bad. Okay, go back, 0.01, 0.1 over 12. Yep. And then raised to 12 times 20, and minus 1. And over 0.1 over 12. So very similar calculation, and we just have to use Excel one more time, get the result. And we can compare just underneath it, right? Quick comparison, yeah. Okay, let's use a bigger font so you can see better. Here you go, so 1,000 times open parentheses 1 plus 0.1 over 12 and raised to 12 times 20, close it, minus 1. That will take out numerator and divide by denominator 0.1 by 12 and close it, right? And we should be able to get a result right away. Okay, and the result turned out to be 759,000. Okay, so the second option turned out to be $759,368 and then change, right? 84 cents. If you look at it, it's not doubling. Actually, it's slightly less than doubling. So that means first option, right? It's pretty decent because even the double rate, you know, because time value of the money is more powerful. So the ending balance did not double, right? Yeah. Okay, 759, 368. So this ending balance 759 and let's see 368.84. 368.84. Okay, and that's how you come up with the ending balance. This is a typical retirement account setting. So you can easily, compare different options if you want to plan for your future, right? In terms of retirement, even you can use it to guide your own personal life or career, or your friends, your family members. Okay. Now, compare the total ending balance. Okay, yeah, we did that. Yes. All right, so now let's take a look at example 8. This is another type of a fund. It's called trust fund. Right? And usually those wealthy individuals, they will set up most of them will set up trust fund to provide, like payments for their, descendants or like family members over a fixed number of years, right? So here, trust fund is set with the goal of providing $30,000 semi-annual payments for 30 years. Meaning semi-annual, meaning the recipient or the recipient of the fund will get $30,000 every 6 months. So on a yearly basis, the recipient will get $60,000 for 30 years. So if the bank in which the fund is created can guarantee 5.5% interest over the life of the trust, how much should be deposited to fully fund the stream of the payments? So now think about this. That's a unique feature here is a semi-annual payment of $30,000 for 30 years. So this one is what we call the regular payment, right? Or semi-annual payment. So this is regular payments. And this is a typical feature of the annuity, right? So we know that this has to be an annuity. And is it the future value or present value of the annuity? How much should be deposited right now, right? So now, meaning whoever created fund, trust fund, have to provide a fund to the bank. So then the fund will start generating the cash flow, right? This regular payments, it's like cash flow over this 30 years period of time. And since we're looking at the deposit amount right now, so this is lump sum payment, but in the present time, right? So this present value of the annuity, first of all, because one-time payment, lump sum payment comes right now. Okay, so once you clarify all this crucial information, and we know that we are talking about the present value of the annuity. Okay, and then we'll be able to just use the formula to get this the present value of all these cash flows, right? Or regular payments over 30 years. So now one more time, let's list all the given information. We know the regular payment, it's 30,000. And we know interest rate, R is 5.5%. Okay, so this is 0.055. Okay. And we know number of compounding period per year, right? So it's twice per year, semi-annual, twice per year. Time T, we also know that is 30 years. Okay. So now if we know all of this, and then we just apply the formula, present value of the annuity equal to regular payment, and 1 minus 1 plus R over N raised to negative NT. Okay, so remember, for the present value of annuity, the exponent is negative, you get a negative sign. Okay, so pay attention to this detail so you do not apply the formula incorrectly. and over our value. Okay. Now, once you have the right formula, then we plug in the numbers. Let's see what that is. Okay, so it will be 30,000 times square bracket 1 minus 1 plus, the rate is 0.055 over 2, right? Because n equal to 2. Okay, and the exponent is negative 2 times 30. Okay, now we get that. And over 0.055 over 2. Okay, and one more time, we're gonna use Excel to get the result. So go up here, let's put into the Excel. Let me try to make it a slightly bigger font size. Okay, here you go. All right, 30,000 multiplied by open parentheses 1 minus 1 plus, the rate is 0.055 over 2, and it's raised to negative 2 times 30. Okay, and close parentheses, that will take care of the numerator, and divide by denominator is the compound interest rate per period, 0.055 by 2. Okay, and now once you input it properly, and should be able to get the fund we need, right? Okay, so it turned out to be, in order to guarantee this result, you need to have $876,679 and change, right? 86 cents in order to fund this kind of a cash flow. So if let's say you are wealthy, and then you have a lot of like funds, you'll be able to provide something like this for your relatives or close family members. Just help them out, right? Let's say provide a college funds or any other like funds for your loved ones, and this is what you could do. Okay, and okay, let me just put in the number 876,000. $679.86. $679. $679.89. Okay, and the follow-up question is, since you let's say you invest this amount of money and your payout is actually more than this. So if you want to calculate the total interest earned in this account, how would you do that? Let's look at it, right? Let's see, looking at the investment, and then let's see how much investment, how much interest you earn from this type of trust fund. So what you can do is multiply 30,000 by 2, right? You get annual withdrawal from the account, and also you multiply by 30. That's total money payout to your recipient. However, you only invest $876,679.89. So the remaining balance become your interest you earn from this account, from this trust fund. And you'll be surprised, actually, this interest is quite large. If you look at it, 330,000. Okay, let's do it together in Excel. You always want to know, what kind of return you're looking at, right? So 30,000 times 2 multiplied by 30, that's a total payout from the bank, and minus previous amount, right? This is the initial investment, and the difference is what we call you see the return on the investment, or interest earned on the investment. And you see the interest earned is quite large, right? It's more than the initial investment. So you earn a lot of interest in this account. 923,000. $320.14. Okay. 923,000. $320.14. You always want to look into these numbers and compare different kind of options. You know, if you have a lot of money available, you can pick different options, right? Let's say this bank offer you 5.5%, maybe the other bank offer you something better, and you can always compare the results. And if you understand the nuance going behind all these different transactions. Okay, any questions so far? Okay. All right, so this is another, hypothetical case. I think this is the last question in the slide. I think so, yeah. Okay, so suppose you win 40 million lottery, right? So if you play the lottery game or Mega Million in New York City, basically the payout is quite large, right? You can win a lot of money, right? Sometimes it could go up all the way to $300 million. It happens, once in a while. So the lottery company will give you the choices of two choices. Usually, you can get a yearly payment, 40 yearly payment of 1 million. If you multiply 40 by 1 million, it looks like you're getting 40 million, right, in total, right? However, think about this. This 40 yearly payments of 1 million is not exactly 40 million, right? Because as time goes by, the value of the money decreases, meaning there's a discount effect of the money. So 1 million today is worth a lot more in the maybe like 1 year from now, right? Or maybe 10 years from now. So that's why this 40 yearly payment of 1 million is not exactly equivalent to 40 million. Okay. So lottery company is kind of a, giving you option of 40 million, but it's like over the 40 years. This is one option. Okay, first option. Second option is you get equivalent lump sum payment right now, meaning you get one-time payment right now. They pay out everything to you, and the lottery company will calculate a lump sum payment based on 5.25% interest rate. Okay, how much will be offered now? So definitely, if you look at it, we're looking at the present value of the annuity, right? You see this keyword now. So this is present value of the annuity, because two elements here. We get a yearly payment of $1 million. Also, that's one-time payment at the current time, right? At the present time. So this is present value of the annuity. And you want to find out what will be the proper payout, one-time payment at the present time. So first of all, we list all the given information here. So the present value, that's what we're looking for, but we know the regular payments, right? It's 1 million. If you want to expand 1 million as expanding number, you can do that, 1 million. We also know the rate. The rate is 5.25%. So you turn the decimal is 0.0525. Okay. And then number of compounding period, N is, okay, it's yearly payment, so it's once per year, right? So N equal to 1. And also we know time T. Time T is 40 years, T equal 40. Okay. And we apply the formula, present value of the annuity equal to regular payment times 1 minus 1 plus R over N to negative NT. And then over R over N. Okay. So one more time, we throw in the numbers into the formula. So this is a million times 1 minus 1 plus rate is 0.0525 and divide by 1. Okay, and it's negative 1 times 40. So negative 40 basically. X exponent and the denominator is 0.0525 over 1. Okay. Now one more time, we just use the Excel to do the work. We do this 1 million. Okay, multiply by 1 minus 1 plus 0.0525 by 1. Okay, and raised to -1 times 20 to 40. Okay, that'll be the numerator. Okay, and let's take care of the denominator. Okay, so it will be 0.0525 by 1. Okay, and we have the proper input. All you have to do is hit enter and get a result. And let's see what that is. You will be surprised how much less you're going to get. Okay, but then let's run it to the decimal number first. Okay, so we get this, right? It looks like you're getting $16,587,497.78. So if you compare to 40 million you earned, right? You win. It's a lot less. It's less than half. But why most people still prefer this option? Do you have anybody think about this? Why most people would take a lump sum payment, one-time payment, which is a lot less compared to $1 million for 40 years? Anybody think through that? Why is that? $187,497.78. Nope, none of you guys get a chance to look into this, or maybe any educated guess why most people prefer the lump sum payment.
I'm just gonna take a guess. I just think it's like that instant, not instant gratification, but it's like when you win something, I would think they just want it immediately and they'll just take whatever. So I just think impatience, I guess.
Okay, that's one reason. Yeah, definitely. This is one reason, definitely very important reason, right? People usually prefer more money right now, right? Instead of $1 million every year, right? Because you get a lot less, and also another concern is, you see, lottery company using 5.25% to calculate this, to discount this regular payments. What if you can find a good brokerage firm or like investment company? They can do better than this rate. That means over 40 years of period, your money will grow a lot quicker compared to this particular lottery company calculation. Meaning maybe in 40 years, if you have a good company running the fund for you, you maybe end up with more than $40 million, right? That's very possible because 5.25% is not a high return. You see, if you hire good people, right people, they may be able to get you maybe anything between 6 to 15% return, right? And then you end up with a lot more compared to this $40 million, lottery gain over the 40 years. And that's another intrinsic reason. And a lot of people won't tell you this because that's why most people take the one-time payment, because you have a lot of high balance, you can easily find the right people do the job for you, and you'll be able to end up with a lot more wealth in the near future, right? Okay, and that's a rationale behind this one-time payment. And also another reason is people usually are anxious, right? They want to see the big money right now. That's human nature, right? Okay. All right. Do you have any question from section 3.3? Or anything puzzles you? You want to any clarification? Okay. If not, no problem. Okay. And we're gonna move on to section 3.4. So I'm going to give you a timeline, what the exam would take place, right? So today is Wednesday. We will be able to finish section 3.4 by Friday. So next Wednesday, we will review for the second exam. And either next Friday, ideally next Friday, you're going to take the exam number 2. Okay. So I give you a more than 1 week notice, right? So it's like 10 days. And I think I post a review sheet on the Blackboard. Let me double check if I did post a review sheet. Otherwise, I'll post it. So let me share the screen with you.
Professor, you mean that the second test is in 10 days?
Yes, will be next Friday.
Okay.
Let me give you the date. If yeah, that will be the tentative. So April 16th, you take the second exam. Let me see if I post the review sheet for the second exam. It's only about the chapter 3, right? So 3.1 all the way to 3.4. So cover 4 sections. Let me see. I do have a review sheet. Yes, it's available. Review test 2. Feel free to look into that. Maybe start working on it. And next Wednesday, we can talk about that. We can review the questions from the sheet. And then next Friday, you take in the exam number 2 or test number 2. Yeah. All right, so now any question on that? Okay. And let's move on to 3.4. And we're going to take a look at more applications in terms of annuities. And we have credit card, like bond pricing, all different topics. And let's look into that. Let me share the screen with you first. So 3.4 is just about more applications, right? So in 3.3, we talk about mortgage, car loan, retirement account, trust fund, lottery, right? Lottery games, or lottery, like all those different kind of Mega Million, all those different kind of fun questions. And 3.4, we're gonna look at more applications, right? So like we're still using the 2 formulas, future value of annuities and the present value of annuities. So the most important thing is find out which formula to use. That's very crucial. So analyze the situation, whatever you encounter, and let's see if it is mainly focus on the future value of annuity or present value of the annuity, and you'll be able to apply the right formula from there. So this is just review of the formulas. And this is present value of the annuity formula. One more time, we have 5 variables here. As long as you know 4 of them, 4 of the variables, then we will be able to find out the missing one, right? And present value of annuity mainly apply for the saving accounts, mortgage, okay, and car loans, right? Okay. All right, so now let's look at the bond pricing one more time. So how to price the bond? Okay, part two meaning this is slightly more complicated. So pay close attention. It's going to be slightly more complicated compared to 0 coupon bond, right? So remember we talk about 0 coupon bond. Basically 0 coupon bond, you get discount when you purchase the bond, and the discount amount is your return on the investment, right? Or your interest earned on the bond. Okay, so now let's see 0 coupon bond. But this is not a 0 coupon bond, right? It's anything else but a 0 coupon bond, because 0 coupon bond is slightly more simple compared to these regular bonds. So for most of corporate bonds or like municipal bond or treasury bonds, usually you have these conditions is you have par value for sure, right? Always, every bond has a par value. And for most of this bond, they will pay dividend, meaning they will pay interest on a regular basis. Like this is a typical setting of the corporate bond, right? If you, let's say, invest in a company, in a public traded company, they will have a bond, right? And it's called corporate bond. Okay, so this is typical corporate bond. And for most of the corporate bond, you get paid on a regular basis, meaning the company will issue you a check. Here it's basically on annual basis, right? Pay yearly. So meaning every year you get 4% of $10,000. Okay, so this is what they call a dividend. You get your dividend is also another way of saying interest. Same thing as interest payment, right? They pay you interest because you loan them money, right? And it's paid on a yearly basis. And the bonds are priced to yield 6%, meaning on the current market, right? If you combine all the bonds and average out the return, every bond has different return, right? If you average all the bonds and then get an average return for all the bonds, and this is the market return, right, for the bonds. So this is price to yield 6%. This is market yield, meaning based on the current market, take into account of all the bonds available out there. On average, you get 6% on your investment. Okay, so this is market rate. So now you want to use this information to find out the price of the bond. Okay, so now think about this. The price of a bond will come from two sources, right? First source is, remember you're getting $10,000. This is $10,000 par value. So you get $10,000 in the near future, right? So $10,000, we got to discount this face value, okay? Okay, so discount of the face value. Or par value. Here is $10,000. Because remember, $10,000 in 10 years, it's worth a lot less right now, right? Yeah. The future value is always, because that's the inflation. So every year the money is worth less. That's why $10,000 in 10 years, it's worth a lot less right now. So this is first source of the price of the bond, right? Discount of the face value. Second source is find out the present value of all these annuities. Remember, all this interest payment on a yearly basis it's an annuity, right? It's regular payment every year. So we need to know how much does all this regular payment worth right now, right? How much are they worth right now? So it's present value of the annuity issue. Okay, and if you look at this, annuity is 4% times $10,000. So every year you're getting $400 check as an interest or dividend. That's what they call the dividend. Yeah. So you're getting $400 dividend for 10 years. So over 10 years, you're getting a total of $4,000. And since it's regular payments on a yearly basis, so we're going to discount that as well. So once you combine the both sources, right, and that will be the real price of the bond. So let's see how much you are willing to pay right now. Okay, so first one, let's discounting this $10,000 using the market rates, right? Meaning on the market, if you have $10,000 to invest, they will pay you 6% interest. Okay, so let's see. In terms of discounting the face value, we're using the compound interest formula. Okay, so present value, future value equal to present value times 1 plus compound interest formula is used. So basically, this $10,000 just compounding yearly basis, right? Okay, and it's going to be R over N to the NT. Okay, And here, that's putting all the given information. So we know the future value is 10,000. We're looking for present value. Okay, 10,000. I think I put in 100,000. Okay. All right. And we also know the rate. You see the market rate is 6%. Remember, we do not use the dividend rate, right? We do not use the dividend yield because dividend, this rate, coupon rate is only used to calculate the dividend, right? Annual dividend, annual interest you receive from this investment. So that's not used, right? So in terms of discounting the face value or calculating the present value of the annuities, we always use the market rate. So 6% here is what we call the market rate. On average, how much do you earn from the average return, right? So that's why it's called market rate. And market rate is what we use to discounting the face value or find the present value of the annuity. And number of compounding period per year is compounding once per year. Time t is equal to 10. Okay. Now, once we have all of this, so we're gonna throw into the formula, find out the present value of this $10,000 in 10 years. Okay. So you do 10,000 equal to present value times 1 plus the rate is 0.06. 0.06 over 1 raised to 1 times 10 power. Okay. And now from there, let's just simplify a little bit. So we get 10,000 for present value times 1 plus 0.06 raised to 10th power. Now present value should be equal to 10,000 over 1.06, right? Or if you want to do 1 plus 0.06 to 10th power, no problem. And let's see what that is. And 10,000 in 10 years is worth a lot less, right? As I mentioned, that's a time value of the money. So definitely it's worth a lot less right now. And let's see how much that is that worth. 10,000 divided by 1 plus 0.06 and close parentheses raised to 10th power. And this should come out as you see, it's only worth $5,583 and then 95 cents right now. Okay, so it's worth a lot less, right? 5583.95. That's what we have. So this is what we call a discounting of the face value. $5,583.95. So bond price come from this 5593.85. For some reason, it's not cooperating. Okay, let me just raise it a little bit. $83.95. 3. So this is discount of the face value. And also we need to find out the present value of all these annuities of $4,000 right, per year. And let's see what that is. So we know that the regular payment here must be 4,000. 4% of 10,000. No, 400, right? Not 4,000. My bad. It's not less. Yeah. Just $400 per year. But you receive that every year for 10 years. Okay, regular payment is that. And the market rate is 6%, so 0.06. Okay. And number compounding period is 1, right? And time t equal 10 years. So based on this, applying the present value of annuity formula, present value for regular payment times 1 minus 1 plus the annual interest rate over number compounding period with negative NT, right, and over our van. All right, and this is the formula. Then we throw in all the numbers into the formula. We get a 400 multiplied by 1 minus 1 plus 0.06 over 1 raised to negative 1 times 10. Okay, that's exponent, and dividing by 0.06 by 1 just 0.06. So you can just write it like that. Let's see what that answer is from this. Okay, so that's put into the Excel. So it's going to be $400 times open parentheses 1 minus 1 plus rate is 0.06 divided by 1 and raised to 10th power, 10 years. And that would be the numerator divided by 0.06 on the denominator. Okay. And that should give us the present value of the annuity. Okay. 1 minus negative 10. I miss a symbol, miss a sign here. Should be negative 10. Okay, that should do it. Okay. Yep. Thanks. Yep. Actually, yeah, we need that. Okay. Too many. That. Read this. And close it. Right. We need that. Okay. And if you want to skip this parenthesis, that's okay. Right? This is totally okay. Just one that. Let's do it. So that means this is what $2,944 and then some change, right? For all this, actually the total is $4,000. Remember, $400 per year for 10 years. But the discounting to the current time, it's only worth $2,944.03. 2944.3. $2,944.03. And the total bump price, you're just going to sum up those two numbers. So discounting two things: face value and then present value of annuities. So the bump price, you combine those, right? Because you receive two incomes, right, from this bond basically. One of them is from the face value, the other one from interest or the dividend payment. So you combine those two, that's your total return, or total bond price. Okay, so 5583.95, adding $2,944, 2944.3. And then the total is the total return. Let's see what that is. You can just combine them or put into the Excel. So it's 98 cents for sure. 7, 2, 1 up 1, 15. So 8527. So the bond price $8,527.98. Okay, we can quickly double check from the Excel. Just combine those two numbers, adding this, and adding those two numbers, and turn out to be 8527.98. Right, so this is how much you will pay for this $10,000 bond, right? And basically, you're actually getting two kind of income, right? First income is from the par value, right? That's why we have to discount that to figure out how much it's worth right now. The other income is from interest income or dividend income on a yearly basis. That's also very crucial. So that's why the bond is worth $8,527.98 right now. Do you have any question on this? And this is totally different from a zero coupon bond, right? For zero coupon bond, you do not receive dividend. You only get a par value, right, in the near future. And that's why you only need to discount the par value. That's why we're using compound interest formula. But for everything else, right, other than the zero coupon bond, it's just slightly more complicated because there are two sources of income for the bond. Okay. Now let's look at example number 2. Let's say 8,000 bond that matures in 20 years has a coupon rate of 5.25% payable yearly. The bond is priced to yield this, so this is market rate, right? What will be the price of the bond? Okay, so for this question, I want you to spend 5 minutes, think about it, how to handle this. So again, the face value of the bond is $8,000. So this is face value or par value. Meaning in 20 years, you receive $8,000. So you need to figure out how much is $8,000 worth right now. Also, since there's a coupon rate, 5.25%, meaning every year you're getting 5.25% of $8,000 for 20 years. And again, that's a regular payment, right, for 20 years. And you want to find out what is the present value of that annuity. So this is the second source of the price in terms of pricing bonds. Okay, so you can try this really quickly, very similar procedure like what we did in example 1, and find out how much is the bond worth right now. Okay. Okay, so let's go over the solution on this. So again, we have two sources of the, we need to discount, right? The first source is the par value. So we're gonna discount the par value. Okay, and second one is find out the present value of the annuity. Okay. Very similar procedure from question 1. So the par value meaning you received $8,000 in 20 years. So the future value equal to 8,000. And then the market rate is 6.5%. Since we can convert it to decimal with a random number, so this is 6.5 over 8 is 625, I believe. But let me double check. Yeah, 0.6, yes. So it's 6.625%. That's a market rate. And turning decimal would be 0.0625. And also we have a compounding period, n equal to 1 and t equal to 20. And now once we have this, so we're gonna do future value equal present value times 1 plus r over n to the nt. Okay. And let's throw in all the numbers. So 8,000 equal to present value times 1 plus, the rate is 0.06625 over 1. And then it's 1 times 20. Okay. So now simplified, so present value P should be equal to 8,000 over 1 plus 0.06625. Raised to 20 power. Okay, and let's see what that is. Right? Going to the Excel, let's find out the answer. Okay, I guess I'll do underneath here. So it's going to be 8,000 divided by 1 plus 0.06625 and raised to 20 power. Okay, and that turned out to be $2,217.73. And that should be, how much is the 8,000 worth right now, right? From 20 years. Okay, so 2217.73. So 8,000 in 20 years is only worth 2217.2373. So it's worth a lot less, all right, for sure. Okay, so we find out that this the present value of the par value. Now let's take a look at the present value of the annuities. So based on the coupon rate, on the dividend is paid based on the coupon rate. So you're gonna do 5.25%. So regular payment equal to 5.25% times $8,000, and a 5.25% is 5.25% by 8,000. And let's see what that is. So it's 0.0525 times 8,000. And it should be $4,020. That should be right, but let me double check. Yeah, it turned out to be $420. That means the interest, annual interest, $420. The rate, again, we're using market rate, is 0.06625. And n equal to 1, t equal to 20. So now again, applying the present value of the annuity formula, present value equal to regular payment times 1 minus 1 plus r over n to negative nt over Alvin. Okay. Since n is 1, we can omit it, but yeah, let's just put in all the numbers first. So it's 420 times 1 minus 1 plus 0.06625 over 1 and raised to negative 20th power. Right? 1 times 20 is 20th. And dividing by 0.06625 by 1, so by default it becomes 0.06625. So you don't have to divide by 1. All right, then one more time, we're just gonna, let's see what this is. Put into the Excel, get a result. Okay, so this is 420 times 1 minus 1 plus 0.0625 and raised to negative 20 power. That'll be the numerator and divide by 0.06625. Okay, and once you have this, then you just hit enter, get a result. And this $420 annual payment for 20 years is worth $4,582.17, right? As of now, 4582.17. 4582.17. Okay. And once you combine these two amounts, this and this amount, that's a bond price. So the total bond price, final bond price, adding 2217.73 by 4582.17. And that should be the total amount. And this amount turned out to be, it should be 0.90, add up to 997 and 6, right? So this bond price is $6,799.90. That should be, let's double check in Excel. I just combine these two amounts, you get a bond price. Yep, 6799.90. Yes, that's good. Okay. Do you have any question on this? Okay. All right. Let's take a look at example 3. So consider the price of the bond in example 2. So now if you look at it, if the bond is now priced to yield 4.75%. So now the market rate decreases, right? Earlier it was 6.67625%. Now the market rate is only 4.75%. Now let's see how much the bond is worth. And then you'll be able to compare how the market rate impact the bond price. Okay, so first source present value of the par value, right? Let's find that. Okay. So now again, the par value is 8,000. So meaning future value is equal to 8,000. And we have the rate now, market rate is 4.75%. So this is 0.0475. Number compounding period is 1. Time t equal 20. Okay. And this is first part. And let's use that to find out the present value. So future value equal present value times 1 plus r over n to the nt. Okay. Put in the numbers, 8,000 equal to present value times 1 plus 0.0475 over 1 raised to 1 times 20, 20th power. So now the present value should be equal to 8,000 dividing by 1 plus 0.0475 to the 20th power. And let's see what that is. Okay. So we're gonna have 8,000. It's worth a lot more, right? Because the rate is lower. 1 plus 0.0475 raised to 20 because the denominator is smaller. If you look at it. So now it's worth $3,162.35. So if you look at it, 8,000 in 20 years is worth 3162.35. Go back, 3162.35. If you compare to the previous one, it's worth more because the market rate is lower. Okay. Now let's find out second source is the present value of other annuities or the dividend income, right? Present value or dividends. Okay. So now one more time, let's find out the dividend. Right? So dividend is based on the coupon rate. Okay, so coupon rate is 5.25%. So the dividend will be the same, right? So regular payment will be $420. It's 8,000 times 5.25% times 8,000. That does not change. Meaning the company will always pay $420 to the bondholder. Okay. And then also we know the rate is 0.0475 now. N equal to 1 and T equal to 20. Okay. So now one more time, we're using the present value of the annuity, regular payment times 1 minus 1 plus. Rate is 0.0475 by 1, so you can just write 0.0475 without dividing by 1. We can omit it and raise to negative 20th power. That would do it for the numerator. Yeah, I should write out the formula one more time before I put in the number. R over N to negative NT. Okay, over R over N. Okay, so now from there we just throw in the number 420 times 1 minus 1 plus. The rate is 0.0475. Omit a 1 in the denominator, raise to negative 20th power, and dividing by 0.0475. And that should give us the present value of all these dividends. Okay, so let's go back here. So it's 420 multiplied by 1 minus 1 plus 0.0475 and raised to negative 20th power, close it. Okay, that's numerator and divide by 0.0475. Okay, and that should do it. And this amount turned out to be $5,346.88. And the total, combined total is the bond price, 346.88. 5346.88. Okay. So the final bond price will be the total of those two. So we have $3,162.35 plus $5,346.88. Okay, let's see what the total is. So 3, 2, and that's 9. And that's 0 again. Carry over 1, 5. And the last one is 8, right? So it's $8,509.23. Okay, let's quickly double check this using Excel. So if you look at these two bond price, actually under the second condition, the bond price is higher. Okay, 8509. So now compare this. Under the first condition, the bond it's only worth 6799.91, right? And then under the second condition, it's worth a lot more, right? It's worth like almost like $1,800 more. So this tells us something. If you go back, look at this condition. Previous condition is, you see this coupon rate is lower than the market rate, meaning the company is paying below the market value, right? Below the market return in terms of the dividend or interest. So that's why the bond is worth less, because the company is not generous, right? It's less generous than the market. And if you look at the second condition, the coupon rate is bigger than the market rate. That tells us that the company is more generous. Right? They pay better than the market rate in terms of dividends, and that's why the bond is worth more. Okay, so it sort of makes sense, right? If you think through this, there's an intrinsic rationale behind all of these transactions. And then I will stop here today because I have a full meeting to attend. We'll be able to finish the remaining topic on Friday, right? And I guess I'll talk to you guys on Friday again. Next Wednesday we review, and then next Friday you will take the test number 2. Okay. Any questions?
Thank
Thank
you.
you.
Thank you.
No, guys. Okay. Talk to you guys on Friday.
Thank you.
No problem.
Professor.
Bye. Yes. Question? Okay. Bye-bye, guys.
Bye, Professor.
Bye.